Now today we're actually going to be taking a look at heat guns. Not this particular heat gun, I've actually gone ahead and I've purchased something that's a bit smaller. So I'm sure you've seen this heat gun used in many of my videos. We use it for things like shrinking down heat shrink and also for drying paint. In fact, there's lots of various tasks that we can use in the electronics workshop for a heat gun like this. So as you can see, the heat gun that I normally use is made by Bosch, and it's a relatively powerful unit in that it's 1800 watts here, so it can put out a lot of heat. Now of course these things are really mainly designed for doing things like paint stripping for melting paint and yeah, scraping it off your windows, gloss plate paint, things like that. It's not necessarily the perfect thing to use in the electronics workshop, and the reason I would say it's not perfect is because it is just so powerful. Now of course the main reason that I've used this heat gun for so long is very simply because this is the one that I have to hand. Now of course it's not necessarily a problem that it is so powerful, because of course you can just move it further away from the job that you're doing, and obviously the heat dissipates with distance from the nozzle here. And this one has actually also got some temperature control on it. It's got basically I think that's, yeah, it's got a warm setting which is just very slightly warm air. So it's got a setting too, and that's what I normally use it on for heat shrink and stuff like that. And that's already really quite hot, that. I've really got to hold my hand all the way over here. And then it's got a setting 3, which is just basically thermonuclear world apocalypse setting. So yes, that really is like having your own private dragon. Now another of the features that I do like about this heat gun is you can effectively use it hands-free, because it will actually stand on its butt here, so you can switch it on and just stand it up, and then you can just hold things above it. So that's quite a nice way to use it, hands-free. So let's just see what some of the temperatures are. So it's set to setting 1 at the moment. So there we go, there's setting 1, and setting 1 is around 60 degrees. It floats around a little bit. There's setting 2 now. So our setting 2 really is quite a big jump there, so that's gone from 50 degrees to 250 degrees. Okay, so let's go to thermonuclear. Around 400 degrees for the top settings. Now I've actually owned this Bosch heat gun for very many years. It must be probably 15 years. The model number for those playing along at home, it's a PHG-600-3, and I've really got no complaints about it, apart from it's maybe just a little bit too big for some of the work that I want to do in the electronics workshop. But as a general purpose heat gun, I don't think you can knock it, and the Bosch build quality is great. So as you can see, I've actually gone ahead and I've actually purchased a much smaller heat gun here, and the main reason that I have purchased another one is just simply due to the fact that it is smaller, and I think it may be better suited to some of the tasks in the electronic workshop that we will be doing. And those tasks would again probably include things like shrinking down heat shrink, and maybe also use it to diagnose thermal faults. I think you'll probably remember that I was actually using my heat gun working on that Trio 9R receiver, where we actually used it to actually track down a fault on a mica capacitor which was thermally affected. But the problem with the Bosch heat gun, it tended to heat up the whole of the chassis. It was very difficult to pinpoint the heat where I wanted it. So again, I just thought this would be better. Now the reason that I'm unboxing this today, well, the truthful answer is because this has been lying around on my kitchen counter now for the last 2 months, and my wife said that if I didn't shift it and do something with it, she was going to put it where the sun doesn't shine.
Come to Skegness and Mablethorpe. It's the fun coast to visit for a fantastic holiday. Live attractions and explosive nighttime magic with great shows and live entertainment.
She was going to put it where the sun doesn't shine, so yes, that's why we're doing it today. So I think I'd say that this isn't particularly going to be a review video, it is more of an unboxing. I know that some of you don't like unboxing videos, and I've got to admit I don't particularly enjoy unboxing videos either. I do think they are the bottom feeders of the YouTube world. And in fact the only thing I think is worse than unboxing videos is actually those reaction videos where, you know, the people don't even make their own content, they're simply reacting to some work that somebody else has done, which is even worse. Okay, so there's first impressions. It's well, as you can see, it's made by a company called TACKLIFE. Now the reason that I went for this particular make and model is because I bought one of their mini drills, which I have reviewed previously. I don't have any connection with the company, they're not paid me, they don't know anything about me. Simply that I bought one of their drills, I thought it was a good product, so I recognised the name TACKLIFE, so I bought another of their products. Alright, okay, as you see it comes with some kind of nozzle. I'm not sure what that does. Maybe it's for doing heat shrink or something like that. So that clips on there like that. I suspect maybe you put a wire in there and you can use it to protect something that's behind it. I'm not exactly sure. Looks as though it hasn't got a lot of heat control on it. We've actually just got two temperatures. We've got a switch here which is basically on or off. Now for some reason I did actually think that it had a little wheel on it that you can control the heat, but I was actually mistaken on that. I got that wrong. So it doesn't have a heat control on it. Now of course, for reasons known only to the manufacturers, it does come fitted with a little plug condom, so we'll get rid of that. Just seemed like just a wasteful packaging. They've gone ahead and they've wired the plug, but they've given us some instructions in case we want to check that, so we'll get rid of that as well. Well, again, I suppose we should just have a look in the plug. Start off by saying, has the plug got any kite marks on it or anything? Any standards? Well, it says it's approved by somebody or other. Don't know, can't read it. Let's just check what fuse it's got in. Would be nice to know that it hasn't got a 13 amp fuse in it, wouldn't it? Okay, so we've got a 3 amp fuse installed in this thing, so we'll go ahead and see what kind of current this thing draws when we plug it in. So I'm guessing that the plastic body on our tool here must all be double insulated, because you can see it's not earthed. Okay, so it feels very, very solid in the hand. There's no flex at all. Now, as you can see, it's also got a couple of rubber grips on it, which I guess they do soften the finish of it slightly, but I've always thought that these rubber grips are somewhat pointless. It seems to be more form than feature. I don't really think they fulfill a purpose. It would feel fine in the hand without them, and in my experience of things like these rubber grips, they always seem to turn a bit nasty and messy after a while. I don't know why, they just seem to, but yes, it feels very solid in the hand. I've just noticed it has some kind of a clip here. I think this is maybe a fold out stand. Do you pull that? Okay, yeah, it has got some kind of a stand on it. Doesn't feel, yeah, that doesn't really inspire confidence. But even though it does fall over on the stand, you can actually see that the hot end here, it's fully enclosed. So that was one of the problems with my other heat gun, in that it had quite a lot of exposed metal, and I have actually managed to just catch the back of my hand on it on occasions when maybe I wasn't being particularly careful. In fact, let's have a look at that. So just bringing back my old Bosch heat gun, you can see there's actually quite a large piece of exposed metal work here. Well, we had this switched on about 10 minutes ago, and ow, that's actually still hot, and we only had it switched on really for a few seconds, and that really did get very hot. Well, you can see there's bits of melted plastic on here, so no doubt at some point in the past I've been working in a radio chassis or something like that, and I've managed to catch the metal nozzle here, and something's melted onto the side of it. And I've certainly also in the past just accidentally caught my hand on it, and even if it's been turned off for a few minutes, this is still blisteringly skin melting hot. So I think that this is really quite a nice feature, the fact that the end is fully shrouded and encapsulated in plastic. So hopefully that will mean that you won't get a burn if we touch that, and in fact we will try that. Now, another of the reasons that I did choose this particular heat gun is that there's quite a few heat guns that you can buy on Amazon and eBay, and some of them are actually quite a lot cheaper than this one. This one was about £16, but you can actually buy them for, I think, even just £6, maybe even £5 on eBay, and they look very, very similar to this. But reading some of the reviews, they didn't get very positive comments, like, you know, first time I used it, it didn't work. Second time I used it, it set on fire. So you never know if that's just user error, but there was such a lot of complaints about some of the very cheap heat guns. I thought I would just spend twice as much. So rather than spending £6, I've spent, you know, a bit more, spent £16, and hopefully we bought a better tool. Now, for all I know, they may all come out the same factory, so I don't know. I guess we won't know that until we plug it in and try it, will we? But back to our hot end here, you can actually see that it is pretty much fully shrouded. You can't really touch the metal unless you really try. So I think that that's probably going to be a good safety feature. Well, I don't think there's too much I can say about this really, is there? I'm not going to pull it apart because this is my tool and I'm not going to risk destroying it. Okay, well, we're all plugged in, so let's switch it on. Well, I've just switched it on and quite a lot of smoke came out of the end of it, but I'm sure that that's just the preservative or something like that. Well, it's giving out a fair amount of heat. Oh, we have smoke. But I've got to admit, it does smell a little bit smoky and toxic in here, so I think I'm just going to go ahead and open a window. Well, I think what I'm going to do is I'm actually going to leave it switched on for 5 minutes because hopefully it should survive 5 minutes without exploding. Let's find out. We've had the heat gun running on the bench now for about 5 minutes and it seems to have stopped smoking and it's still working okay. Well, amazingly enough, I can actually still touch the nozzle here. Well, at least the shroud around the nozzle. That is, well, it's certainly hot, but I'm not in danger of burning myself, so I think that's really quite a big win. The rest of the handle it's warm, it's not cold, it's just warm, it's not uncomfortable. Now, of course, in the real world, I doubt you'd actually have this thing switched on for 5 minutes. It's the sort of thing you would use for 30 seconds to heat a piece of heat shrink and then you turn it off again. So this has been running for 5 minutes now, so that does show that it has got some very good thermal insulation around it. Now, of course, being a man, I haven't bothered to actually read the instructions for this. There's quite enough information for me printed on the side of the tool. So it says here it's a TACKLIFE, and the model number for those playing at home, it's an HGP35AC. The voltage is from 230 volts to 240, 50 hertz, and it's 350 watts. And I'm guessing that 350 watts, that's going to be a combination of both the heating element and also the electric motor power supply. So 350 watts in total. It says the air temperature is approximately 350 degrees output and the air flow is 280 litres per minute, and it's made in China. Now we've also got various official standard looking stamps here. So we've got a Rolsch label here, which basically means it's lead free, etc. I think that's what Rolsch means. R-O, is it Roche? Roche, whatever. So basically it's a lead free product. It's got a CE mark on it, so that could be a certificate of conformity, or it could stand for Chinese engineering, who can tell. It's also got a TUV sticker, which actually gives me some faith in that, you know, it has had some testing on it. So assuming this is actually a proper TUV test house sticker, that should be good. Next to that we've got two little squares. Well, that means that this tool is double insulated, and as we saw, it didn't have an earth on it. So it should be double insulated, so that means that there's no exposed metal parts here that you could get a shock from. And I think what we'll do is we'll actually go ahead and we can prove that it is double insulated. We'll try that with my tester in a minute. I think that it's got various recycling type stickers on it, and the picture of a wheelie bin. I think that says do not put it in the bin. I don't know why we shouldn't put it in the bin. Certainly when it breaks, that's what I'll be doing with it. Well, as you can see, I've gone ahead and we've got our old friend the Claire tester on the bench, because what I'm going to do is we're going to check that the double insulated rating of this tool is up to it. So it has got this little two squares next to each other, so that means that this tool is double insulated, and what that means is that none of these parts here should be at all conductive. There should be no connection between these metal parts and the mains electrical supply. So if you had something like a failure in the insulation of an electric motor, or a failure in the insulation of our heating element that's in here. That may actually show up here as an electrical resistance between any conductive metal parts and the actual mains wiring coming into the tool. So basically what we're testing against is that there's no possibility of any of the conductive parts on this tool becoming live to the mains. So that's the test that we're going to do. Now I've got to admit, I'm not very familiar with this particular test because most of the equipment I work on is actually earthed, so we would normally plug in an earth lead to it, but because this is double insulated there is no earth lead. So what we're going to be doing is we're going to be doing something called a flash test. So what that's going to do, it's going to apply a voltage of 3000 volts between the mains input cable and any of the metal exposed parts on the body of this tool. But before I do that, because I've never actually done one before, I don't think I've ever tested a piece of double insulated equipment, I just want to see what this Clare tester does. So these testers come with some plugs like this. This is a test unit and it comes with a black plug and a white one. So the white plug is actually used for, I think it's for earth continuity testing, and this black plug here is actually used to test the high voltage double insulation testing. So there's actually a little brass stud on the bottom of here, and it's actually not very convenient to get to. Maybe they do that on purpose because this could be high voltage on it perhaps. So what we're going to do is we're going to touch the end of this contact tip here. You can see even this contact tip is all very well insulated, and you press this button and it exposes the tip. And of course they have to be quite careful because there's 3000 volts on here. So let's plug that in, and I have to press the test button, and let's see, this should produce a fail. Did you see the arc? I'm not sure if it caught it on the camera. Okay, and we get a fail light there. Let's do that again. Okay, so that's what we're looking for. We're looking for this fail light coming on, and it says that insulation flash fail. And for this test the tool does need to be switched on, so we'll switch the main switch to the on position. I'm going to put it on the bench, and now I've got to be very careful not to touch the parts with my hands because you know, I could get a shock. Can I put that stand out? Will that stop it from wibbling around? Hopefully. Right, okay, so I take my tool here, and first of all what we're going to do is we're going to touch this screw here. So I turn it on, the test probe is now live, we've got 3000 volts on it. Touch the screw, okay, stays at pass, so that's okay. So the next part of the tool we're going to test is this metal nozzle at the end here where the hot air comes out of. So we press the test button again, touch the tool to it. Okay, and it stays on pass. So that's okay, that's good, that's safe. Well, I guess we should also go ahead and just measure the temperature of the hot air coming out of the heat gun, so let's try that. Well, it looks like the maximum temperature that I can measure is about just over 300 degrees. It does say 350, that may be true, but I actually am happy it's slightly cooler. I'm happier towards 300 than 350 or 400. I prefer this tool to be a little bit cooler for what I'm doing with it, which is literally just going to be melting heat shrink and looking for thermally related faults. Well, as we saw earlier, this tool does come with this little piece of bent tin, which I guess is some form of heat deflector. I think this is actually used when you're actually trying to put heat shrink on wires, in that you put your wire in the little groove here in the valley, and then I think the idea is that the shape of this actually stops the heat going forward and maybe damaging something in a cabinet or behind your wire. So it's just a heat shield. So let's put that on there. Does that fit on there? Does it push on? Yeah, that pushes on there like that. And I guess we need a wire and a piece of heat shrink, so let's find some. I'll tell you what, let's try without the heat shield first. So just here's a piece of quite large heat shrink, so I'm just going to grab hold of that in a pair of pincers here and turn that on. Okay, as you can see, it did that without any problems. I think it was probably a little bit slower to do it than using my big Bosch heat gun, but I suppose that's what you would expect. Now, I said earlier, one of the problems with my Bosch heat gun, it's actually too hot. You can actually burn the heat shrink material if you overdo it. So I think what I might do is I'm gonna hold this in the hot airflow, and I'm gonna see how easy it is, or even if it's possible to burn the heat shrink. So let's try that. Well, it does look very, very slightly singed, but it's certainly not burning. I think we need to do a comparison test. Let's get out the big Bosch heat gun. Well, it certainly is possible to melt this piece of heat shrink with the big heat gun, but I've got to be honest, I think I was somewhat overstating my case, because this Bosch heat gun it's orders of magnitude more powerful, and I really did have to hold the heat gun on here in order to actually make this heat shrink material burn. So yeah, maybe I was overstating my case slightly, but certainly the smaller, the little TACKLIFE heat gun, it is a lot cooler, and for doing things like heat shrink, I think that is an advantage. So this has been switched off maybe about 30 seconds, and the nozzle is still in excess of 160 degrees, so yes, you can really burn yourself on this thing quite easily. So I think that really does prove the point that the shrouding on here does a great job. Yeah, the only downside that I'm really seeing with this tool at the moment is this stand. I think the problem is the lead on the back of the tool. It's not very flexible. It's not as flexible as it could be. So if you've got any twist or bend, it can tend to just throw the tool over. It's a shame they didn't make this a little bit wider, but I suppose they were trying to keep the stand within the ergonomics, within this, keeping it tight into the body. But yeah, the stand is a bit of a letdown. But on the other hand, the fact that this is actually cool to the touch, you can turn it on like that and you can put it down without any worry that it is going to melt anything on your bench. So maybe you wouldn't use the stand. The only time I can think that you would use the stand is if you were trying to use a tool in a static application, if you want it switched on like that. So I'm going to put that heat shield back on it. And here's a piece of equipment wire that's come out of the junk bin, and this is tri-rated equipment cable wire, so I'm just going to push that on there, switch it on. Okay, it does do quite a nice job of that, no problem. I wonder if it will melt the wire. Okay, certainly it will melt the wire, but you've really got to hold it in the heat for quite a while, so yeah, I think that works well. So I think that this little heat shroud here, it actually fulfills two things. One, it actually ensures that your piece of heat shrink here, because the air hits it and curls round, it actually heats the heat shrink all the way round, so you don't have to move the heat gun round. This little deflector ensures that your heat shrink does get shrunk on all the sides at once, so that's an advantage. The fact the tool again doesn't get too hot means that you're less likely to melt the wire, because I've certainly done that lots of times in the past with my big heat gun. I've been a little bit careless, I've used too much heat and I've melted this wire. Certainly you've really got to over egg it to melt the wire using this heat gun. And I think the other advantage is that it probably minimises the heat in front of the tool here. So if you were doing this heat shrinking inside a radio chassis, you've got capacitors and other wires and equipment behind it here, haven't you? So you don't want to end up melting that. I wonder if we can just prove that. So let's switch that on. I'm going to see how much of a difference it makes. Well, I think that test is amazingly conclusive. You can see that I can keep my hand there with the heat gun full on. That would have just melted my hand off at the wrist if that had been the big Bosch heat gun. So far, again, we're only talking about electronic usage here. We're not talking about stripping the paint off doors. I think that this tool should have some good utility in the electronics workshop. It is a shame that they don't do some form of heat control. I would have liked to have seen maybe a selector switch here with like maybe a low range and a high range. That would have been nice. Or maybe if it just had hot and blow, you know, so you can actually blow cold air with it. That would have been a nice feature if they'd have put a free position switch on here, but they haven't. We've just got on-off control and we've got no temperature control. Now I know that another job that these heat guns are used for, they use them for warming up plastic conduits so you can put a bend in them. So I just thought we'll just try warming it up and just see if we can get this plastic into a malleable state. Of course, I'm sure we'll be able to, why wouldn't we? Okay, I detect some wibble wobble in it there. So the idea is we should be able to put a bend in that. Well, I think for today that'll do. It's a heat gun and it gets hot. It does what it says on the tin. So until next time, as always, thanks very much for watching and I'll see you again next time. But bye bye for now.